to another edition of Series 2, part where we look at superposition and the reality states that arise from that. Now, as you can see, it's got the sun shining straight through the window this morning, and I've brought Wordley out to say hello as well, because you haven't seen him for a while. He's doing much better these days. He's molted out. He's looking fantastic, in fact, and we're very happy with that. Poor little dove makes progress. In another reality, of course, there is no Wordley. He didn't make it, and in that reality I am not existing at this present moment in time. However, that doesn't mean to say that that version of reality isn't there. It's simply that, like Wordley's ability to fly, it's a time thing. Some physicists will tell you that the sum total of quantum mechanics is where a particle is at any given time. In actual fact, I've just watched a video where a very popular and famous scientist in England actually said that very thing to sum up what quantum mechanics was. Quantum mechanics is the bedrock of reality. It's sliding doors effect, it's the spread of probabilities, the options that are available within it, and the way in which those options operate. That's quantum mechanics. The reality that arises from that we experience is a bit of a misnomer, because it's something of an illusion, the reality that we experience. This episode looks at the superposition element and goes into more depth about the waveform and how it operates across the variable effect, the sum over histories effect of quantum mechanical implications. Here I've drawn what may be familiar to many of you as Schrodinger's cat, because in Schrodinger's thought experiment, his cat is both alive and dead at the same time. That's a sleeping cat because it's nicer. But essentially the principle is that until a situation is observed, it has a superpositioned state, i.e. it exists in more than one condition. All the possible conditions exist until observation collapses the particles into a version of reality that we can identify. The reality of superposition is that there are infinitely variable options constantly on the way in which something can pan out, the way in which something can realize itself, can manifest itself. The atomic structure would suggest that the electron and photon, which are jumping up and down in the energy states, and the proton and the neutron in the middle, which are comprised of quarks just swirling around and being different versions of themselves all the time. These constructs of the atom are self-observational, one could say. We know from experiments that the very fact that we've set up an experiment and create the conditions for the experiment to take place will affect the outcome. This is called the observer effect. It goes very deeply into the realms of quantum mechanics and the principles that underpin the reality we perceive. Now, because quantum mechanics is so fuzzy, There are a lot of thought experiments out there to describe what really happens and to bring a concept into a visualization, a mentally visible construct. One of these is called Wigners' friend paradox, and this thought experiment is well worth looking up, but I'll give you a little snippet pictorially right now. This essentially tells us that it doesn't matter what you're doing or who you're with or whose reality you're sharing, you are entangled with the situation that you are existing within. And so is the other party. They are also entangled with your reality and the situation that you are existing in.
Remember that your reality is
Remember that your reality and my reality are a long way apart in time. I've made this video and I'm making this video right now. But in your reality, you're watching the video in some considerable distance in time down the line. That doesn't prevent the entanglement. The situations have come together. My making the video, you're watching the video, that is an entangled situation. There are choices involved in the equation, and this is very much part and parcel of the quantum mechanical state, is the definition of choice and where it sits in the process. So the more condensed we get, the closer we get to one or other of these probabilities. Paradoxically, the fuzzier it gets. And that too is part and parcel of the quantum state. The nature of atoms, electrons, their behaviour, what they do within the structure of the atom is all very fuzzy and variable continually. The probability is that when you walk into your room tomorrow or later today, the lamp on the table will still be there. It'll be the same lamp, it'll be still in the same place on the table. That's a probability. However, the construct of the atoms, the position that the electrons are in, will all be variable, and they'll be changing all the time. So the lamp itself is solid, but the construct within it is continually variable. The Wigner friend paradox takes this into the human domain and allows us to look at how people and relationships and perceptions of reality become entangled with each other. And again, we have variables because everybody's point of view, even in the same circumstance, is going to be slightly different. Just as within the atom, every electron is going to occupy a slightly different position in the shell valence. Here there's a little diagram at the bottom. This is a representation of what is known as a Feynman's diagram. Because in physics papers, these lines will have a particle attached to them. It could be any kind of particle attached, but they will follow the same basic law that this diagram is representing, and that's why it's interesting. So when you see this diagram in physics papers, expect to see a particle on each end of these little sticks here. The interesting bit is the time variable. The Feynman's diagram, the mother-daughter particle in the middle that is produced by and then produces these particles that go forwards and backwards in time simultaneously, is a particle coming in on our standard time frame that we experience, which is the forward motion of time from present to future. And the other particle will be going in the opposite direction. The other particle will be going from future to past. That's how a Feynman's diagram generally works. At the other end, you've got the particles that these two particles came together and then decayed into. And they too will be on the same kind of time traversal system. You will have this particle travelling on the timeline that we're familiar with, from present to future, and the other particle going effectively backwards in time, from future towards the past. Why is this important? Because what's in the middle, the mother-daughter particle in the middle, is a particle that comes into existence as a result of the combination of these two particles and then decays, as it's known, or turns into two more particles. It could be more than two particles, it could be three particles. It depends on what the situation is, and it depends on what these characters are each side of the fence. But this particle here, this intersecting point, is essentially what is produced as a collapse of these two time variables. And that gives you an idea of how quantum reality actually works in the superposition state. There's more about this in other videos, so you can rummage around in the quantumology box and look up some videos that relate to this, and you can then explore further as to how it relates to you. So enjoy, have fun, take care, love you loads, and I'll see you again very soon. Bye.